Let's take a closer look at the atom. Now, atoms are made of smaller subatomic particles, right? Subatomic particles means smaller than the atom. So, what are these subatomic particles? These subatomic particles are called protons, neutrons, and electrons. Protons, as with the experiments that were made by Rutherford, Bohr, and Chadwick, we have since agreed that protons and neutrons are found in the nucleus, right smack in the center of the atom. Very, very small. Okay? The symbol for protons can be noted by the lowercase letter p with a superscript positive sign at the top right corner of the letter. The symbol for neutrons can be used by a lowercase n as well as a superscript not or zero symbol sign at the top right corner as well. Electrons are found outside the nucleus. They are outside the nucleus. Okay, the nucleus may be this small, right in the center, maybe really small, and the electrons are outside there. Now, electrons are represented with a symbol lowercase e with a superscript negative sign at the top right corner. The amount of protons, neutrons, and electrons for any atom would really be determined by what type of atom it is. Okay? So, for example, lithium has 3 protons, 3 electrons, and 4 neutrons. A type of lithium, all right? Now, it is also important to know that when we talk about subatomic particles, some of these subatomic particles will carry a charge. For protons, it has a positive charge. For neutrons, it has no charge, which means it's neutral. Electrons have a negative charge. For any given atom, it is very important to note that the amount of protons and electrons will always be the same. The amount of protons and electrons will always be the same. This is why we can say that atoms are electrically neutral. Okay? So let's take a look at the structure of the atom. Here I have the same structure of lithium. The lithium atom. One type of lithium atom. Now, the protons and neutrons are at the center of the atom in the nucleus. Alright? And the electrons and the protons we used this blue circle with a plus sign to represent protons. And we used this black circle here to indicate neutrons. Outside of the nucleus, where the protons and neutrons are, we have electrons. Electrons are indicated by these circular lines called shells, and each electron is symbolized by a smaller circle, negative. Now, I know that in my picture, the protons and neutrons look like the same size of the electrons, but in reality, I don't have enough space, so in actual fact, it should be much bigger. Protons and neutrons should be much bigger. And in reality, the electrons should be much, much further away. But due to the lack of space, I have to put it all together in here. Alright? And your books will do the same thing too. But in reality, it's a much different picture. Alright. Now, we know that atom is a type of matter. Right? It is the fundamental matter. And all matter occupies mass and has mass and occupies space. We know that. But since the atom is so small and we can't see atom, how do we know how heavy that is? Well, in these modern days, we have a special machine called a mass spectrometer that can determine the mass of any atom. But for us, since we don't have a mass spectrometer in the school lab, we can determine the mass of an atom by the amount of protons and neutrons. Alright? And we can also use the periodic table to help do that, determine the number of protons and neutrons. Since the mass of the protons and neutrons is so small, these mass spectrometers determine the mass of the protons and neutrons by comparing it with a standard. And this standard is the carbon-12 atom. Alright? The carbon-12 atom is basically a baseline where all the other mass of all the other atoms and also the subatomic particles, protons and neutrons and electrons are compared to. For example, the mass of a kilogram is determined by this really weird cylinder that is out there in France. And this cylinder is made of platinum and iridium alloy. And this alloy basically determines the mass for any kilogram of any matter anywhere in this world. Alright? And it's put in a very nice sealed compartment. And so for us chemists and physicists, we have agreed to use carbon-12 as that standard. So let's summarize what we've learned today about subatomic particles. Subatomic particles, proton, has a symbol of P+, has a positive charge, and we have determined through experiments that proton has a relative charge, or relative mass, of 1. Alright? This 1 comes from the standard that we use with carbon-12. And where are protons found? In the nucleus. And the symbol, the diagrammic symbol used to represent protons is this sign right here. Neutrons, alright, is represented with the ends of naught or ends of 0. There's no charge. It is also almost or just about as heavy as protons with a relative mass of 1. It's also found in the nucleus and is usually represented in simple drawings with a circle. Finally, electrons is denoted by the symbol E of negatives. There's a negative charge. It is really, really, really tiny. We know this because through experiments done by all these famous scientists, that it is 1/1840 of the mass of protons and neutrons. So it's almost like 1/2000th the mass of protons and neutrons. So it's really, really, really tiny. That's why electrons do not really contribute much to the mass of an atom. Electrons are found outside the nucleus and is usually noted by a smaller negative sign symbol, circle, right here. Next time, we'll focus on how to look at the symbols on the periodic table.